So this video is on the Martingale strategy when playing the game of roulette in a casino. And the way this game works is that you start with a bankroll and you begin with an initial bet and you double your bet after every loss until you win. And what will happen is that once you win, after after some consecutive losses, you're going to recover all your losses and gain a net profit that is the same as your initial bet. So what I want to do is focus on the mathematics of this strategy. So we're going to assume that the gambler is going to bet on the color red, and assuming that the gambler is playing one trial, betting on red only once, then the probability of a win is 18 reds out of a total of 38 options. 38 options because 18 are red, 18 black, and 2 green. This probability turns out to be 47.37%. Okay, and therefore the probability of a loss on the same bet is 20 out of 38. So again, that's because there are 2 greens, which we consider as neutral, and 18 blacks. This probability is, of course, higher. It's 52.63%. Okay, so this is definitely not a fair game. Let's assume that the gambler has a bankroll of $127. Now you can try this with any amount of bankroll, like $2,000, $3,000, $200,000, or whatever. And to keep things simple, let's just assume that the initial bet is $1. So again, this initial bet could be any amount. And let's see what happens when the gambler loses in consecutive bets. So if the gambler loses in consecutive bets, then he's or she's giving away a total loss of, well, the initial bet, which is $1, in addition to the double of the initial bet, which is $2, plus $4, which is the double of the previous amount. So the next one is 8, which is a double of $4. And if the gambler is playing n games, the amount of loss on the nth game is actually 2 to the power of n minus 1. Hopefully you can see why, because when so this is the first game. On the first game, we have 2 to the 0, which is 1. This is the second game, which is 2 to the power of 1. Third game, that's 2 to the power of 2. That would be 4, 2 to the power of 2. So as you see, n is 1 less than the number of games. So for the nth game, the amount of loss is 2 to the power of n minus 1. Again, this is assuming that the initial bet was just $1. Okay, now if you have some knowledge of what's called a geometric series, this is a finite geometric series. It's the sum of the first n terms. There is a formula to this, which is going to be the initial amount, 1 in this case, times 2 to the power of n minus 1 divided by 2 minus 1. Here 2 is the fact that the money is being doubled. That's called the ratio of the geometric series. So for example, for 4 consecutive losses, okay, we have a loss of $1 in addition to 2, 4, and 8. So if you were to add these up, you're going to end up with 15, okay, which according to this formula, which I can actually write as 2 to the power of n minus 1, that's because the bottom is just 1. I have a consistency. Okay, so here we have 4 games. So, and here is 4, so that be 2 to the power of 4 minus 1. That's 16 minus 1, which is equal to 15. So you can see that these two numbers match, meaning that if I want to get the total loss, instead of adding the amount of loss one by one, I can use this formula. So, for example, if the gambler is playing the game 10 times, I don't have to add the amount of loss for 10 games. I can just put 10 here for n. All right. So say again, the amount of bankroll is $127. Then the number of times that the gambler can play the game is going to be 2 to the n minus 1 is less than or equal to 127. This tells you what n is. N has to be 7. Okay, so the gambler can play the game 7 times before going totally bankrupt. Now, the probability of 7 consecutive losses is the probability of loss, which would be 20 out of 38 times itself 7 times. We're multiplying because each trial, the outcome on each trial is independent of the outcome on the previous trials. And that would give you 20 out of 38 to the power of 7, which turns out to be approximately 0.059 or 5.9%. Okay, which means that the probability of success is 1 minus the probability of 7 consecutive losses and that's 1 minus 0.059, which is around 0.941. Okay, so this seems to be a fairly high probability, meaning that the gambler is highly likely to walk away with a profit. But keep in mind that the gamblers play a game over and over. So we want to know what the expected value is, meaning that if the game is played repeatedly, on average, how much does the gambler is expected to win or lose? Okay, so we're calculating what is called the expected or average value. And if you've had some statistics, this is the same as the probability of success times profit plus the probability of loss times the amount lost, right? And the probability of success, we just calculate it to be 0.941, okay, times the profit of 1. Keep in mind that if the gambler wins after n consecutive losses, the gambler is going to get a profit that is equal to the initial amount. So here we assume that the profit is 1. And then plus, this is a part of the formula for expected value, probability of loss of 0.059 times the amount lost, which is the entire bankroll of $127. Okay, and this gives you 0.941 times 1, which is 0.941. And then we have a positive times a negative number. So a negative, the product is 7.493, which turns out to be a negative amount of $6.55. So that is the expected amount of loss, not profit. So in a long run, this game is not beneficial. Of course, the games in casinos are designed so that in a long run, you lose. And therefore, the casino benefits. In this case, the casino benefits $6.55. Okay, now you could see some people on YouTube that play this game, right? On day one, they bet $2,000. On day two, they bet $4,000, $8,000, and so on, until they win. And let's say they lose 3 times in a row and they started with $2,000. After the third win, they are going to walk away with all their money back with a profit of $2,000. But you have to keep in mind that casinos are aware of the strategy. So they impose a limitation on the amount that you can bet in a game of roulette. Okay, so you know if you lose n consecutive times and you have to bet, say, $30,000, then the casino would not allow that. That would be beyond, let's say, the maximum, if the maximum is set to be $30,000. Okay, so if this game works, if there is no limitation on the amount bet, and if you have virtually infinitely or infinite amount of money.